Okay, so this is 4.3, which is called polynomial division. So what we're going to do is we're going to learn two different methods today on how to divide polynomials. The first method is using long division, which I call the old school method. I don't know how you learned to divide in grade school, but I'm going to show you the old school method to divide because that's the way we're going to divide our polynomials today. So, old school method, we have 37 divided by 2. Do not get out your calculator and tell me that it's blah, blah, blah. No, that's not how we do this. We're doing it old school. Old school method, you have a division bar. Remember this way back when? And you'd stick what you were dividing underneath, and we'd stick what we were dividing by on the outside. Remember this? It's probably been a hot minute, but hopefully you remember it. And the way that you approach these problems is you go term by term or unit by unit, where I'm looking at 2. And so I go to my tens place in here, and I say, how many times does 2 go into 3? And we don't want to go over. Yeah, it just goes in once. So I put the 1 up here, and then I take 1 times 2, which is 2, and I write that below my 3. Then I draw my line. I change my sign. Draw the line, change the sign. It kind of rhymes. Draw the line, change the sign. Then I subtract. So 3 take away 2 is 1, and I bring down my 7. Now I do the same process where I say, okay, 2 goes into 17 how many times? 8. 8 times 2 is 16. Draw the line, change the sign. And now I have a 1, but I have nothing left to pull down. So that's my remainder. And depending on how you learned this, sometimes you would just note the remainder. Sometimes you'd put like an R1. But this is how it's actually done. You stick your remainder over what you divided by and add it to the end. You stick your remainder over what you divided by and you stick it on the end. So 37 divided by 2 is 18.5. If you want to know some terms, this is called your dividend. What you divided by is your divisor. And then the number on top is your remainder. So if you like the mathy terms, I will probably never say dividend. I might say divisor. Dividend always makes me think of money, not numbers. But this old school method of division is actually how we're going to divide our polynomials. We're going to make a division bar, and we're going to go unit by unit or term by term asking how many times does this go into this? And we're going to write it on top. So I like to show it with numbers first because almost everybody has seen it with numbers at least somewhere in their mathematical career at some point. It may have been a minute. But now we're going to apply that to polynomials. This first example says to divide in order to determine if x plus 1 and x minus 3 are factors of x to the third plus 2x squared minus 5x minus 6. So we're going to do division twice in this problem. We have to do it one time with the x plus 3 or x plus 1, and we have to do it another time with the x minus 3. And I did put a note in here that if a factor is actually a factor of the polynomial, then it's not going to have a remainder. If we do this process and we get down here and we have a remainder, then it's not a factor. If we do this long division process and we get 0 down here, then it is a factor. So let me slide up. And I'm just going to start with this first one. We have x plus 1, so that's going to be the one I start with. X plus 1 on the outside, and I stick my polynomial underneath. The x to the third plus 2x squared minus 5x minus 6. Now, obviously this is a little different than just with numbers because we have pluses and all this other stuff going on. But we're still going to look at the first term and the first term. So I'm going to look at the x, and I'm looking at the first term underneath in my dividend, which is the x to the third. What do I multiply x by to get to x to the third? X squared. So I'm going to take x squared times x, which gives me x to the third. I take x squared times the positive 1. That'll give me a positive x squared. Then I draw my line and change my signs. Change my sign. X third minus x third means that goes away. That's the whole point. We want that to go away so we can keep moving on down our polynomial. We have a 2x squared minus x squared, which will give me an x squared. And then I bring down my next term. I just bring down the first of my next terms. I don't bring down all of them. But then I say the exact same thing. I'm looking at x and I'm looking at x squared. What do I multiply x by to give me x squared? X. So I'm going to put a plus x on top. I put a plus because I'm taking it times a positive x. If it had been a negative, then I would put a minus x. But x times x will give me x squared. X times 1 will give me a positive x. I draw my line. I change my signs. My x squared terms will fall away. Negative x to the fifth, or negative 5x minus x will give me a negative 6x, and then I bring down my last term. What do I multiply x by to give me a negative 6x? Negative 6. Negative 6 times x will give me a negative 6x. Negative 6 times 1 will give me a negative 6. I draw my line. I change my signs. So they were negative, now they become positive. Negative 6x plus 6x gives me 0. Negative 6 plus 6 gives me 0. That's what we want to see. Since this has a remainder of 0, then we can say x plus 1 is a factor of our polynomial. If we would have gotten anything else down there, we'd have to say it wasn't. Questions? So we have to do this process again because we're not done with that problem. It wanted us to also see if x minus 3 was a factor. So we're going to do the same thing. So I ask, x goes into x to the third. What do I multiply them by? X squared. So x squared times x will give me x to the third. X squared times a negative 3 will give me a negative 3x squared. Draw my line. Change my signs. My x to the thirds go away, and then I have 2x squared plus 3x squared, which will give me 5x squared. And I bring down my next term. What do I multiply x by to give me 5x squared? Yeah, 5x. So I put a plus 5x on top. 5x times x will give me my 5x squared. 5x times negative 3 will give me a negative 15x. Sorry, I'm moving everything. There we go. Draw my line. Change my signs. X squareds go away. I have a negative 5x plus 15x, which will give me, that's the wrong color. Not that it matters, but 10x, and I bring down my minus 6. What do I multiply x by to give me 10x? 10. So I have 10x. 10 times negative 3 will give me a negative 30. Draw my line, change my signs. Negative 6 plus 30 will give me 24. Is x minus 3 a factor of this polynomial? No. We got something that wasn't 0 down here, so it is not a factor. Questions on how that works? On how we, yes?
The polynomials only have like 3 factors, right?
Do what?
It can only have 3 factors, so like possible.
Those are the maximum number of zeros, yeah, because it's a third degree polynomial.
So because we got like the solutions for the last one, and there was 2 more.
If we had 2 more, but we don't know which ones are true and which ones aren't. It's like testing the values, like on previous things where if I said x plus 3 equals 7, test if x equals negative 2 is a valid solution. Like I can pull out any number I want. That doesn't guarantee that it's a solution. I only have one x value that's going to work here, but I have to test is kind of what we're doing. We're doing a test process. But yes, if we were actually solving and finding the zeros, the maximum we could find would be 3 for this one. All right, let's get one of our theorems in here. Told you there's 2 theorems today. Our first one is a remainder theorem. Can you see that? That seems really bright. Is that better? Let me get it a little bit away from the sun. Maybe that's better. So the remainder theorem says if a number c is substituted into the polynomial f of x, then the result, f of c, is the remainder that is obtained by dividing f of x by x minus c. We're going to do examples. It'll make more sense. But what's neat about it is if we do this big, long division thing, kind of like we did on that previous problem. We did this big, long division thing, and we got a remainder of 24. What that's telling us is if I plug in 3 into this polynomial function, I'm going to get 24. That's what my remainder theorem tells me. So the remainder theorem is a really nice, quick way to kind of check, at least to make sure that we got our remainder correct. Because odds are, if you do the long division and you get the remainder correct, then you did everything else correct in between it. See what this actually looks like in a problem form. We are going to, example, find h of negative 1 and h of 3 for h of x equals x to the third plus 2x squared minus 5x minus 6, which is actually the exact polynomial we just had. We're going to find these 2 values, and I'm going to show you something neat. Although I already said it, but. So remember, when you find a function at a specific value, what we're doing is we're plugging that value into the function and just computing what it is. So I'm plugging negative 1 into this function anywhere that there is an x. And let me just go ahead and offer up some advice because I saw this a bit on the last test. When you plug this in, use parentheses because there's a big difference between, I mean, there's not when it's to the third, but over here when it's squared, there's a big difference whether or not you use parentheses or not. And I saw this mistake come up a couple of times on the last test. Plus 2 times negative 1 squared minus 5 times negative 1 minus 6. That'll be positive 2, positive 5, negative 6. So notice, what do I get? 0. Well, look what we had a minute ago. When we did long division and we had x plus 1, we got 0. You can't see that. 0. X plus 1 is the same thing as x minus a negative 1. And according to our remainder theorem, if we plug this negative 1 into the function, we should get out the remainder. And that's what we got out. So knowing that, what are we going to get out when we plug in h of 3? Yeah, we better get 24. Because that's what we got out over here. When we did our long division, we got a remainder of 24. So when we plug 3 into this function, we should get out 24. So let's make sure that's true. We have 3 to the third power plus 2 times 3 squared minus 5 times 3 minus 6. 3 to the third is 27 plus 2 times 9 is 18 minus 15 minus 6. Let's see, this gets me to 3, that gets me negative 3, and that gets me to 24. Gosh, it's all crooked. Sorry, guys. It's not crooked on my screen, and it's not crooked over here, but it's crooked up there. So the remainder theorem is very cool in that we do get to do kind of a quick check there to make sure that we did it correctly. Are there questions on the remainder theorem or on long division, aka old school division? Okay. There's another form of division that we can use when dividing polynomials, and it's called synthetic division. Has anybody ever heard of synthetic division? Okay, hopefully some, most. Synthetic division is nice because if you, long division, okay, it's fine. But it's long, thus long division. It takes up a lot of paper space. You have multiple steps. Synthetic division is pretty short, sweet, and to the point. Okay? And we're going to use the exact same functions and numbers that we've been using so you can see how it plays out in this format as well. There's not notes for it. You just kind of have to see it to know how to use it. Okay? So we're going to use synthetic division to divide the x to the third plus 2x squared minus 5x minus 6 by the x plus 1 and x minus 3. Now, at this point, we know what's going to happen when we divide by these things. But that's kind of why I keep reusing it, because we at least know we're doing our math correct, and you can see how it works. So, synthetic division uses the coefficients of our terms. That's what we're going to use. Synthetic division looks like this. Long division, we have a big division bar, and we stick what we're like a dividend underneath and our divisor out front. What we're doing down here with synthetic division is we just have this one little box. That's it. And in that box goes what we are dividing by. And we get what we're dividing by over here. So our first one is this x plus 1. Set it equal to 0. Solve. And you get x equals negative 1. That negative 1 is what's going to go in our box. Okay? Now, outside of our box, we are going to list the coefficients of our polynomial function. So the coefficient for the x to the third spot is 1. The coefficient for the x squared spot is 2. The coefficient for the next one is -5 and -6. You always want your polynomial functions to be written in descending order, and if you are missing one of your numbers, you have to put in a placeholder. Here's what I mean by that. Let's say this problem had been x to the third plus 2x squared minus 6. Let's say we didn't have an x term. Okay, when we go to do synthetic division or long division, we would have to put in a 0 placeholder there. So we would have plus 0x term, and that way we have a 0 here. We don't just get to leave it blank. Okay, that's true even with numbers. If you think about the number 102, we don't just write 1, 2, because that's 12. We have a 0 in there for our tens placeholder. So we have 1, 0, 2, and that's what we would do here. Okay, so we nearly have it all set up. You would draw an arrow here and a line, and whatever this first term is, you write below here. And this is how we set up synthetic division every single time. We have a box. We write our coefficients in descending order, using placeholders if necessary. We draw an arrow down from the first one, and we write the first one directly underneath our line. Okay? This looks weird. I know it looks weird. Go with it. You're going to love it in a minute. Now, what we do to actually do synthetic division is we take what's in our box, we multiply what's below. So -1 times 1 is what? -1. We write that right here underneath the next term, and we add down. So 2 plus a -1 will give us +1. Then we do the same thing again. -1 times 1 gives me -1. I add down. -5, -1 will give me -6. -1 times a -6 will give me a +6. I write that up there. I add down, and I get 0. And you're like, okay, this is weird. I don't understand what it did. Okay, well, we started with an x to the third polynomial, yeah? We're dividing by an x, yeah? So what's x to the third divided by x? X squared. So these were the coefficients of starting with x to the third. These are the coefficients starting with x squared. So that I have x squared plus x minus 6. And if you look back at the beginning, when we did long division with x plus 1, we got x squared plus x minus 6, and we had no remainder. And that's exactly what we got here. X squared plus x minus 6 with 0 remainder.
Can you repeat how you got x squared as the first?
Okay, we start with our coefficients of our polynomial, which was x to the third. We're dividing by an x. So x to the third divided by x will give us an x squared. So this starts with x squared down here. Does that make sense? Okay. Because what we can do is, like, we have this and we have the x plus 1. Like, we could go further and we could factor this and find all the zeros for this polynomial function. Like, you can be asked to solve using the long division or synthetic division method. All right, let's do synthetic division again so we can see how it works with this x minus 3. So for x minus 3, we set that equal to 0. We add the 3 over, and we get x equals 3. So that's going to go in our box. We have 1, 2, -5, -6. So in our box goes 3 this time. So 3 times 1 is 3. So we put that here below the 2, and we add down, which gives us 5. 3 times 5 is 15. And then we add down. 3 times 10 is 30. And then we add down. Again, we started with an x to the third divided by an x, so we're getting down to x squared. We have x squared plus 5x plus 10 plus 24 over the x minus 3, which is exactly what we got when we did long division over here. We have x squared plus 5x plus 10. We had a remainder of 24 that we would stick over what we divided by. So long division and synthetic division give you the exact same answers. They're just two different methods. Most students, I'd say, prefer the synthetic division because it's nice, sweet, takes up 2 lines, 3 lines, and you get it in and out and you're done. Are there questions on this one? On either how we did it using long division or how we did it using synthetic? Do we see how over here, when we have no remainder, we could continue on and we could factor this to where it would be x plus 3 and x minus 2, and we could find all of our zeros, and we'd get 3 of them like you mentioned earlier, because we would have -1, -3, and +2. So we do use these to actually find all of our zeros and actually solve our polynomial functions. Okay, let's get that last theorem in here. We have our factor theorem. For a polynomial f of x, if f of c equals 0, then x minus c is a factor of f of x. AKA, we plug in the c value. If we get 0, that's just kind of an extension of our remainder theorem that we just talked about. Because remember, if we plug c in, whatever we get out is the remainder. So this is telling us that we're getting 0 remainder, and if we get 0 remainder, then it is a factor. So there's a couple different ways you can actually go about this. It says determine if 5 is a 0 or factor of a g of x function. Now, the first way to do it would be using our remainder theorem, where we plug 5 into the function and we see what we get. Because our factor theorem says if we plug 5 into the function and we get 0, then it's a factor. So let's see what g of 5 is to get started. G of 5 would be 5 to the 4th minus 26 times 5 squared. These are some big numbers. Plus 25. Do what?
3,125.
Okay. Minus, what's 26 times 25?
Oh, I didn't do that yet.
Oh.
I'm just going to double check, so I'm pretty sure.
I was like, I'm just going off what you gotta tell me.
625 times
26 times 5. Yeah, I don't think that's right. Alright, let me turn my phone. 5 to the 4th. It's just 625. You went way too big. This is 625.
Oh, yeah.
Oh.
It's 125 and then
Yeah.
65. Oh, right.
So 26 times 25 is 650 plus 25. So we have 625 minus 650 is a negative 25 plus 25, which is 0. We plugged in 5 we get out 0. That means 5 is a factor of this polynomial function. The other way you can approach this, and the way that I actually did it in the notes, is using synthetic division. So synthetic division, we'd set up our box. We use our coefficients. Now look, though. Look at our polynomial function. We have an x to the 4th, so we start there with 1. But then what's our x to the 3rd? Yeah, we don't have one, so we got to put a placeholder in. So we're going to put a 0. Our x squared is a negative 26. We have a 0 for our x, and then we have 25. Draw my line down, draw my 1. We're going to stick 5 in that box. Five times 1 is 5, add down. 5 times 5 is 25, add down. Negative 5, add down. Negative 25, add down. Notice how we got a 0 remainder there as well. Either way is totally fine. Either way proves that we're not going to get a remainder, and since we don't get a remainder, then this is verifying that we do get a 0 or a factor for this given polynomial.